Hey guys, BuildZoid here, and today we're going to be doing a BIOS walkthrough for the Maximus 11 Gene motherboard. So then, you can clearly see we're in the BIOS and we're going to start going through. So just from the first tab we're in. So right here is the Extreme Tweaker. This is where you have 99% of your sort of overclocking settings. So the first thing we get is a bunch of overclocking presets. I never use any of these, but they are here if you feel like using them. We have a bunch of sort of like extreme overclocking presets right here. All right, then we have some gaming preset, like we have some more normal presets right around here. Then we have some more LN2 presets down here. So yeah, and actually you have decent descriptions for each of the profiles on down here, so you can see what each of them does. Anyway, so then we go back here, and the first thing we have is AI Overclock Tuner. And this is how you control how the, like, honestly, I'm not sure why they have that, like, so this is how you can choose which mode you're kind of, well, no, like, this is how you enable, like, basically basic overclocking. So if you just put it on manual, it gives you access to all of your overclocking settings. If you put it on XMP, it gives you access to all of the overclocking settings. It also enables XMP. And that prompt you get right there is essentially, if you hit yes on this, you'll get basically it'll tweak some of the turbo settings for the CPU. So if you want to run Intel defaults, then you'd want to actually run no. This is also how you get your memory, like your XMP profile for your memory. And then there's XMP2, which actually is the one that no, I'm actually not sure what the difference between them is. I don't know why ASUS has a freaking, like, everybody else who, like, all the normal board vendors. Okay, so what does this do? Seems like it just preloads a bunch of extra XMP settings, I think. The annoying, yeah. So that also loads up just more of the XMP profile, I assume. So either way, that's your options there. Quite frankly, like, I still don't know why ASUS has it this way, but it is a thing. So you can choose between manual or XMP. If you have memory sticks with an XMP profile, you may find that having them in XMP1 or XMP2 improves your memory overclocking capabilities. But a lot of the time you can just stay in manual if you intend to, like, manually set all your memory settings anyway. Right, so and we're just going to go with XMP1 here just so that we actually have the XMP profile available right here. First thing we get to play with is the BCLK. You know, LGA 1151 motherboards, most of the high-end ones offer a external clock gen, so you can actually push this ridiculously high. Like, well, that wouldn't really work right now, but you can mess around with this a lot, and it won't affect things like your PCIe speed or your SATA speed or anything like that. But at the same time, it's really, like, it's decent. Like, you might want to use it for, like, fine-tuning overclocks, but generally not worth it, because if you increase your BCLK by 1, that is literally a 1% overclock, and therefore a 1% performance improvement. Doesn't really matter unless you're benchmarking, right? So you can, because the thing is, it still alters things like it'll alter your uncore, your core clock, and your memory clock. So in a lot of situations, it's like, yeah, like, you can use that. It just doesn't really help you in any way. Like, for day-to-day usage, fine-tuning to the 1% level is kind of excessive. So that's kind of that. You know, you can still use it if you feel like it. Then we have ASUS multi-core enhancement. So we have enforce all limits, let BIOS optimize, and remove all limits. So this basically alters the turbo behavior of the CPU. I'm going to say you just leave it undisabled and worry about manually overclocking everything. Then we have SVID behavior. So this alters the stock voltage behavior of the CPU. So you can have best case scenario, typical scenario, worst case scenario, Intel failsafe. So This is like if your CPU is really good, so it's going to run lower voltages. If you go typical, that's like supposed to be an average CPU. Worst case scenarios, more voltage, even more voltage. Again, I would just recommend that you manually set up everything. That way you don't have to, like, well, I mean, you could mess with this, but I just don't know why. Right? Like, it's easier to just lock the CPU to 5 gigahertz all the time, and then you don't have to worry about if the turbo boost is being stupid or not. Then we have AVX instruction core ratio negative offset. So basically, if you run AVX instructions, you can drop your core clock. That's all it really does, and it means, like, the point of this is that you can essentially stabilize overclocks for AVX. Like, you can have you can test an overclock to be like, you can have an overclock that can do, like, maybe, I don't know, 5.1 gigahertz non-AVX, and then when you hit AVX workloads, it clocks down to 4.9 gigahertz, which means you can pass stability with a lower voltage. So yeah, that's the idea behind that. Unfortunately, it doesn't allow you to, there's no way to, like, dynamically drop your AVX workload voltage. So essentially, if you run a lot of eCore, like, AVX is still going to be really, really hard to cool. It's just not going to be quite as unstable as it would normally be. So anyway, next we have CPU core ratio. We have syncall cores per core, AI optimized. We're just going to go, so per core. So the funny thing about this is actually one core ratio limit. So essentially what these are is they're not actually, like, you're not setting the speed for core 1 or core 2 or core 3. You're saying that if there's a single core workload, you can go up to 5.3 gigahertz. And if there's a 2-core workload, you can go up to 5.2 gigahertz. And if there's a 3-core workload, you can go up to, like, I don't know, maybe 5.2 again. And if there's also a 4-core workload, you can say maybe 5.2 again, and then 5.1. You get the idea. You can also just, like, you can also use this to have the CPU dynamically downclock if you just, like, set all of them to the same thing. So if we want this to be 50, actually, wait, I'm setting that wrong. So if you just set them all to 50, like that, that would give you an all-core 5 gigahertz overclock, but it will dynamically downclock at idle. And you'll still get that behavior even if you just use syncall cores. And come back up. So yeah, if you use syncall cores and you don't, like, mess around with your various power saving settings, you'll still downclock for idle. So I, again, wouldn't really bother messing with the per core thing. But hey, if you feel like spending a lot of extra, putting a lot of extra time and effort into things for not a lot of extra performance, because keep in mind, 5.1 gigahertz is only about 2% faster than 5 gigahertz, right? So fine tuning your single core and dual core and triple core and, quad core ratios, like, you can, but it's probably a waste of time. So it's easier to just max out all core because that's nice and simple. So we're going to go with 5 here. And then we got BCLK to DRAM frequency ratio. You can just leave this auto. Essentially, like, no, there's really no reason to bother with, like, changing this, because essentially it just restricts how many different how many memory ratios you have access to. So, like, if we put this to 1 to 100 and we go here, you can see that all of our memory ratios are now multiples of 100. If we go to 100 to 133, you get a bunch of other, you get, a completely different set of memory ratios. And then we have DRAM odd ratio mode. So that's odd ratios. So if we disable that, we can further restrict how many memory multipliers we have access to. So yeah, then you get like 4266. And actually, did that make any difference? Oh yeah, it made a slight difference. Things like 2533 disappeared, right? So you can see how essentially you can restrict how many multipliers you have access to by fiddling with these. But if you just leave them all on auto, you can just, pick and choose ratios that don't suck. That's, like, also an option. So yeah, though I guess maybe, well, no, it's not really useful for forcing certain combinations as far as I'm concerned. So yeah, like, you can use the restrictions. I don't really see the point with doing that. Also, well, I can't get the BIOS to do it right now, but there's a like an annoying thing with ASUS BIOSes where, oh yeah, no, you can see like we can't see where our BIOS options are until you go one down, right? Like your selection is. So that's just an annoying little bug with the ASUS BIOS. Extreme tweaking. This is meant to help. I think it's 3D Mark 01 or something. It essentially improves performance for some really old benchmarks. There's really no downside to having it enabled, but there's also like no point in having it enabled unless you're benching those old benchmarks. So, you know, you can fiddle with having that turned on or turned off and see how that works out for you. Then we have CPU SVID support. So this essentially allows you to disable communication between the CPU and the voltage regulator. So if you're doing manual overclocking, you're going to want to disable that. And if you're, you know, using like offset voltage, you may want to have that enabled. I generally don't use offset voltage because it's a pain to dial in and it doesn't really do that much for your idle power consumption because modern CPUs have a whole lot of power gating. So essentially, even if your CPU is idling on like a really high voltage, it won't actually be pulling that much current because like a good chunk of the silicon won't be active when it's sitting at idle. And so it's not going to pull that much power. Now, yes, you could reduce your idle power consumption even more by using offset voltage, but then you have to also deal with like a completely different, you know, like you need to do your stability fine-tuning completely differently to account for the fact that your voltage isn't constant. So that's kind of that. So I prefer to just run that disabled and then manual core voltage. And we'll go into these various menu items later. Let's go down here. So next we get CPU core cache current limit. There's no reason... I didn't even know this mode was available. There's no reason to not have that maxed out, so you can just max that out. The thing about current limits is essentially they're just there to enforce, like there's no point. They're just max it out. Because essentially if you had this set to something lower, it would essentially just make the CPU power throttle when it starts trying to exceed the current limit. And I would assume you want maximum performance from your setup, wouldn't you? So that's kind of that. I'm also not sure what it defaults to on auto. It might, like, auto might actually be just maxed out as well, but there's no reason to not max it out yourself and know for a fact that it's maxed out. So that's that. Then there's ring down bin. Essentially, what is it? They actually have a good description down here. CPU will downbin the ring ratio, which means the requested max may not be observed. Oh, so essentially what that does is if you are, like if you have 5 gigahertz CPU clock, you won't be able to set 5 gigahertz ring ratio as well if you have this enabled. Like you could set it to 5 gigahertz, but the CPU will automatically clock it down to like 4.8 or something. I think is the down bin. I'm not sure. But it basically won't let you max out, like it won't let you run a stupid high ring rate, won't let you run ring ratio equal to core clock. But there's, again, as far as I'm concerned, no point to worry about that, as you can just have it disabled and run 48 like a reasonable person anyway, right? Like, why would you set the max ratio higher than your core ratio anyway? So next we have BCLK aware adaptive voltage. So if you are using adaptive or offset voltage, this will automatically adjust your voltage based on how much BCLK you have. Disable that. Right, we're doing manual overclocking. We do not worry about that. Then we have manual and offset mode voltage control. Offset mode looks like this. I don't know how it works. I don't really care. There's manual mode where you literally just set whatever voltage you have, and that's the voltage you get. Once you account for like load line and that. But basically, this is the easy way to do your overclocking as far as I'm concerned. So we're just gonna go and set 1.3. And for the Intel 14 nanometer CPUs, the safe core voltages are technically all the way up to like 1.42 volts, which is why even in this BIOS, it's still yellow, right? And if we keep raising it, I mean, yeah, they turn it pink a little bit late, but You can push a lot of voltage into a 14 nanometer Intel CPU, and it's safe for from the sort of like voltage perspective. The issue is it's completely uncoolable. Okay, like at this point you're looking at direct die, full custom water cooling loop, and I'm still not sure that on a 9900K you could handle this. On a 7700K with a custom water loop and liquid metal under the IHS and liquid metal on, well, no, you don't need to go that far, but liquid metal under the IHS, like delidded, on a 7700K, this is actually viable. On an 8086K, this isn't viable already, and then on a 9900K, it's even more of a problem because the 9900K is 8 cores instead of 6 cores compared to the 8700K or 8086K, and it's even hotter, therefore. But the voltage itself, up to 1.4 volts, would be totally viable if it weren't for the fact that it's completely uncoolable. So do keep that in mind. Generally, you're going to want to stick to the sort of 1.3 to 1.35 volts range, which is still pretty damn hard to cool. It's just nowhere near as bad as 1.42. So that's kind of that. Then we have DRAM voltage, which this is the memory. This is just straight up memory voltage. So this is what your memory sticks run on. You can set it all the way up to like 1.5 volts is safe for day-to-day usage. So it says LN2 disabled. I wonder if I have this board in LN2 mode right now. I guess I do. So yeah, this board lets you set a lot of memory voltage. Now, if you're just doing if you're doing benchmarking for HWBot on like Samsung BDI, and you want to be safe, you're going to want to stick to around like 1.85 volts, which is already really high, but it's not anywhere as dangerous as say 2 volts. 2 volts is like where I tend to sit because I don't really care. I don't really care that much for my memory sticks, I guess. They've still not degraded, so I'm either extremely lucky or it's fine. But then up to 2.1 volts, like at this point, I do remember reading that at this point, like 2.1 volts, you're starting to run into the territory of this might be bad for the CPU's memory controller. And past that, it's like you should really be running the CPU sub-zero if you want to run any more memory voltage. Now, for day-to-day usage, you're going to want to stick to around 1.5 volts. Not all DDR4 memory even scales that high, but the memory that does scale that high, you're going to want to, you can go up to 1.5 volts. It is worth noting that DDR4 memory, lots of DDR4 memory chips are actually temperature sensitive in the sense that they lose stability if they get too hot. That is different from degrading, okay? Like DDR4 is rated to survive all the way up to like 85 degrees Celsius. And that's like the lowest temperature rating you can buy. There's industrial grade DDR4 where it's like up to 95. But if you're looking at so temperature wise in terms of endurance, you don't have to worry about it. The issue is a lot of memory ICs, if they get like 5 degrees hotter, it totally changes the memory timings you can or can't run. So while if you have decent case airflow and you're in a relatively cool environment, running 1.5 volts is totally viable for daily. You may find that your specific memory kit in your specific case may or may not clock better at slightly lower voltages like 1.4 or 1.45 volts, right? So as 1.5 volts is totally safe. It's just that it may lead to such high, to elevated temperatures to the point that your memory might be happier at a slightly lower voltage. So that's kind of that. Next we get CPU VCCIO and VCCSA. So both of these are memory controller voltages. For day-to-day usage, you want to keep them under 1.35 volts, which is also conveniently the point where ASUS tells you that they're too high by turning them red. Now, if you're doing benchmarking, you may end up at, say, like 1.5 volts and other horrible numbers that will slowly chew away at the memory controller and make your CPU steadily worse at memory overclocking the longer you keep it at that voltage. But if you're a normal person, you're not going to go above 1.35 volts. And more importantly, if you're not even going over like 4,000 megahertz, then you can probably stay in the sort of 1.25 volts range, and you'll be completely fine. Then we have, of course, CPU system agent, which is the same thing. It's just a different part of the memory controller and the CPU, but the same voltage rules apply to both of them. Basically, you don't have to crank them up super high unless you're doing some ridiculous memory settings. And for day-to-day usage, you really shouldn't be going over 1.35 for either of them. They do potentially sweet spot so that is something to keep in mind. You might have to dial them in a bit. But a lot of the time, more is just better with these. Okay, like a lot of the time, if you can't even post, raising them tends to help. But honestly, whenever I do any memory overclocking, I just sort of start at 1.25 volts and go from there. If I'm going significantly past 4,000 megahertz, then we're looking at like 1.3, 1.35, maybe even 1.4 volts if we're in like the 4,600 megahertz plus range, or 4,000 megahertz plus on like 32 gigs of RAM. But you know, for day-to-day usage, that's not really applicable. So yeah, you're going to want to stay under 1.35 for both of these. So that's what those do. And they do affect your memory stability. And we'll just whack 1.5 in there. And we have PLL termination voltage. This can sometimes help with memory overclocking to just set it to like 1.1 volts. But ultimately, this voltage is one of those voltages, like this is an extreme overclocking voltage. You really shouldn't have to do anything with it, ever. So just leaving it auto and not having the motherboard in LN2 mode is a good idea, because if you do have the board in LN2 mode, it'll actually it'll preset a bunch of the auto voltages to very high, well, potentially quite high levels. Yeah, for day-to-day usage, you know, just auto, or if you feel like it, you can lock it to 1.05, which is the default for that voltage, which ASUS kindly tells us that's what it should be if you're running like Intel voltage rules. So then we have PCH voltage, so that's our chipset voltage. This voltage does absolutely nothing. Okay, like literally you do not need to worry about it. You can also just lock it to 1.05. I've seen sometimes if you're maybe like, well, sometimes on LN2 it might make sense to raise it a little bit, but even that, like, I don't normally bother with that. Like, I normally just run it at 1.05 or auto, so don't need to worry about that one. Yeah, this voltage being currently at 1.2 volts, that's because I have LN2 mode enabled on the motherboard. This voltage, you're going to really, like, for day-to-day usage, you don't have to worry about it. So that is way too high. So you'd want to have it at, like, 1.05 volts. If the board isn't in LN2 mode, it wouldn't be at 1.2 volts, but yeah. So you don't need to worry about this one either, because it's primarily for like if you're doing extreme overclocking, there's a few issues that tweaking that voltage can solve. If you're doing day-to-day overclocking, that voltage does literally nothing. Okay, you don't have to worry about it. It may as well not exist. That's why on a lot of other motherboards, you won't even find that setting. Okay, so, and then we get to DRAM reference voltage control here, and so the annoying thing with all of these is that these seem to be raw 8-bit values, because, yeah, you can see how that one goes to like 63. So I'm not actually sure what units those are set in, and these are like, this is just a thing with the ASUS Maximus extreme overclocking boards. They give you access to a lot of memories, like a lot of settings that on a lot of other motherboards, you wouldn't be able to get to them. Because you don't need to get to them. Honestly, just leave all of this on auto and forget that this section of the BIOS exists. You know, if you're doing some benchmarking, extreme overclocking, it might make sense to tweak your memory reference voltages. And so the reference voltages, what they do is actually they set the sort of zero value as a ratio of the memory voltage. So like this is 0.5 times VDIM. Okay, and raising this too high is bad. And quite frankly, auto is 0.5 times. Okay, and auto works generally the best. You shouldn't need to mess with this ever. So again, this is one of those settings, like, honestly, I've never needed to use this setting myself. Okay, so you can just leave that on auto and forget that it exists, like everything else in that menu, which is quite extensive. But yeah, like this is just stuff that ASUS seems to leave on their boards for when, I guess they're doing like testing at ROG, like when ASUS engineers are working on the boards or something like that, because I've never had a reason to ever like mess with anything in here. So you don't have to worry about those. And next we're going to take a look at our DRAM timing control settings. And okay, we need to go all the way back up. So up here we have a bunch of memory presets again. So we have 2x4 Hynix, bunch of options, bunch of different profiles. I'm gonna like these seem to be from like X299 days, except that one. That one seemed like, or Hynix, like, oh, these Hynix sticks might have really sucked. That one of the two. Then we have some micron profiles, which these are really bad. You have a bunch of Samsung profiles. You just have profiles for all kinds of memory. These may or may not be useful. Oh, then we get some Samsung BDI profiles. These are actually useful if you're doing extreme overclocking. For day-to-day, you're going to want, like, you might want to run this one right here. Yeah, so it's kind of that. So you do have a bunch of memory profiles in here like this, and then you have more for Hynix, more for Micron, Samsung, just memory profiles for days. So yeah, and there's a raw memory frequency profile. So if you load up any of those, they'll basically set a bunch of, like, they'll set voltages and a bunch of memory timings for you. And they can make it real, like, if you have a memory kit that's on the same, like a CPU that's of the same quality and a memory kit of the same quality as what one of those profiles is built for, they can make your life really easy because you just load the profile and bam, you've got a bunch of really good memory settings. And you can do a bunch, you know, like, you're ready to bench whatever benchmark you feel like, and you don't need to worry about the memory timings because they're already going to be set really, like, they're going to be set up properly for you. The downside is that some of those profiles don't actually, like, a lot of those profiles may not work for whatever memory kit you try to run them with. So that is something to keep in mind. So then we get our Maximus tweak setting right here. Mode 2 seems to work better for some, like, so you can leave this auto, but you're gonna, like, if you're doing memory overclocking, changing this can make sense. But I've not yet, like, noticed a specific scenario in which one of them is, like, a specific reason to go from one to the other. So yeah, I'm not going to tell you which one of them is for what because I don't know, and there's nothing saying which one's for what. But basically, if you're doing some memory overclocking and you max out and you can't go any higher, and you've been using mode 1 for the entire time that you've been doing your overclocking, at that point it might make sense to switch to mode 2 and see if things improve or if they get worse. And if they get worse, well, you know not to use mode 2 at that point, and if they get better, well, you can continue going from there. So that's kind of that. Then we get, our timings. Worth noting with ASUS motherboards is they actually combine your TRCD settings with your TRP settings. So that's why you only have, like, you have cast latency, TRCD, and then TRAS, but there's no TRP, and the reason why is because on LGA 1151, TRP is equal to TRAS. So here, you set both of them with one entry in the BIOS. It configures both of them. So right now we're running 18, 20, 20, 39, not 18, 20, 39, because that's not a thing. So yeah, and if we go to this, then we're running 18, 16, 16, 39. So it's kind of that. That's our timings. Then we have command rate. I don't know what that setting is. Never tried it, but you get your standard sort of command rate options: 1 tick, 2 tick, 3 tick. Then we have, all of our standard memory timings. We have our TRRDs, refresh cycle, so TRFC, TREFI, TWR. Yeah, they actually just, like, they're right there in the hints. So that's kind of that. So we have all of those. We have some menu items that we'll go into later. TRRD, then we have our tertiary timings. For anyone wondering, the SG at the, this timing right here, so actually all of the tertiary timings, essentially what these control is back-to-back operations. So for example, this one here is like read-to-read delay, same group. And same group is basically memory, DDR4 is built up of bank groups. And there's different banks in the same group. So this affects timing delays for reads, like consecutive read commands from different banks in the same group. Then you have read commands in a different group, right? So that's what the DG is for. And then we have read to write, same thing, write to write delays, write to read. And you can see how, write to read has to have a really long delay. Don't ask me why that is. It's just how DDR4 works. So Yeah, and then here we finally see a difference. So this is one of the differences between ASUS and a lot of the other board vendors in terms of how they lay out their timings, is now we go back to read delays, but DR and DD means different rank and different DIM. So this is for if you're running multiple memory ranks or multiple memory DIMs on the same channel, not on different memory channels. Or actually, different DIM might be across channels. I'm not 100% certain. Anyway, that's what the endings mean. I'm not 100% sure what they do. I don't spend that much time memory overclocking, okay? I don't know why everybody keeps wanting me to do a guide on it. Then we get more memory timings because it never ends. Why would it end? So here you can disable memory, like MRC fast boot. If you have fast boot enabled, it'll essentially skip memory training. So this is useful if you train a set of memory settings and you don't want the board to like randomly stop booting on you. The issue with this is that, well, potentially you can boot up with some really unstable memory settings if you have MRC fast boot enabled. So generally you're going to want that disabled if you actually care about stability. But if you're going for something like maximum memory frequency validations, it might make sense to disable it. I mean, enable the fast boot. So yeah. Anyway, we're going to leave that, like most of the time you should just leave that on auto. Then we have DRAM clock period, which I have no idea what that is. Memory scrambler, again, no idea what that is. There's settings here that I've never seen before. Channel A, so this is kind of cool. You can actually disable memory DIMMs. How does that work? This board only has 2 DIMM slots. I kind of feel like they've taken a 4-DIMM BIOS and just kind of kludged it together for this motherboard, but yeah. So you can choose, like, you can disable DIMMs on each memory channel on the fly, so we're just going to go with that. Have them both enabled. Then we have trace centering. I've had some success with enabling this for dual rank when I was trying to push high memory frequency. This is a memory training thing. Okay, I'm just going to put it that way because that's basically my level of understanding that. If you're doing day-to-day settings, you're just going to want to leave that disabled probably. If you're doing, you know, more like if you're doing some competitive overclocking, it might make sense to enable this. I don't know. It's definitely not like a setting that'll be harmful. It's just like I'm not sure when it's useful. So that's that. Then we have MCH full check. You know, and yeah, we have a perfectly good description for this one. Right, this one doesn't have a description, but this one has a perfectly good description. So, you know, enabled checks for stability, disabled doesn't check for stability. You can potentially boot some even less stable settings if you feel like it. So then we have training profile, and I have, wait, let's see what the standard oops. No idea what these do either. So that's kind of that. Then we have DLL, BWEN. Just go with the advice from the motherboard there. Again, I have no idea what this is supposed to do, but it's a thing, and it can help with memory overclocking sometimes. Then we have DRAM SPD write. So this is actually I think there's some RGB memory kits where you might have to enable that, but most of the time you should just leave that disabled. You don't really want to accidentally corrupt your memory's SPD profile, because if you do, you're going to be screwed. Well, unless you have like a hardware flasher device with which you can recover it. But otherwise, that's going to give you a bad day. So you should probably leave that disabled most of the time. Then there's XTU setting, which I assume is some very obscure tweak to get higher scores out of Intel's XTU benchmark. So we're just going to go with that. And I'm like, again, no idea what that does, but it's a thing. So yeah, they don't even have a good description for it, but it exists. So yeah, plenty of settings to mess with. More settings than I can keep track of. So next we have SKU control. So here you actually find your DIMM termination settings. So, you know, on-die termination for the memory DIMMs. And for whatever reason, instead of having them, you know, set in, like, labeled in ohms, which is, like, what they should be labeled in, ASUS has them labeled in DRAM clocks because ASUS is ASUS, and I don't know. Like, honestly, I have no idea what they're trying to do. Because it's like, I assume this is to be some kind of obfuscation to prevent people from copying their memory settings. But the thing is, if you don't actually do anything, these are all on auto, right? So you don't actually know what they're doing. And if they're not on auto and you're changing them, then you already know what all of these values, that all of these values are supposed to be in ohms anyway. So I don't know what labeling them in DRAM clocks achieves, but it's a thing. So yeah. Anyway, then we have a whole bunch of memory settings that I have no idea what these do, but there's a lot of them. I assume all of the settings down here are basically for optimizing signal integrity, but I don't have any idea what any of them do, because there's just way too damn many of them. And most motherboards, you don't have access to these settings, because on most motherboards, the board vendors, you know, they go out of their way to make sure that the auto rules for all of these timings are, well, all of these settings. I'm not even sure that these are timings. I have no idea what they are. But that all of these are actually configured properly for your memory. And this is one of the things where, like, board vendors can make a really, like, distinguish themselves compared to other board vendors where, you know, if you don't have the auto rules for these dialed in, it makes memory overclocking on some motherboards suck really badly, because you know, you're just stuck with whatever rules Intel has set for all of these. And those may not be optimal for frequencies in excess of, I don't know, say 3200 megahertz or 3600 megahertz. So, yeah, this is where a lot of the sort of BIOS memory timing up, like BIOS memory frequency capability optimizations come in, and that's from the board vendors. So, yeah, that's why you normally don't see these. And the fact that ASUS has these exposed is actually kind of strange, but they're still set all to auto, so it's like you can't see what they actually are. I have no idea how to use those either. Anyway, next we get RTLs and IOLs. Now, these are, again, another part of the memory overclocking capabilities of this board, where it's like, this is basically magic. But I have a rough idea of what all of these do. So RTL stands for RTL stands for round trip latency. And essentially all of these timings are, well, the issue with all of these timings is that these are actual timings, that these are actually dependent on your memory time, like your other memory timings, because they set certain, like, I'm not sure what exactly the latency settings they're configuring, but these can make a huge difference to your memory stability, and it can sometimes make sense. Like, what can sometimes happen is that the motherboard will boot up and you'll get something like 51, right? Or no, you'll get something like 49, and then you'll get like 56 here, and you'll have 6, 6. Well, actually, no, that one would be auto. What is it? IOL 4, 4. So that's dim 0 rank 1, dim 1 rank 0, dim 1 rank 1. So this one would also be, and then, well, like this one would be 8. Okay, and when that kind of thing happens, then essentially you'd call that a RTL miss, because the motherboard sets these during the post procedure. And what can sometimes happen is it'll figure out how to set one of the memory channels correctly, and it'll just completely screw up on the other one. So, for example, like 49, so when this happens, for example, you would do like 49, and you'd set your second channel to 50, and then you'd set the 8 to 6, and 49, 50, 6, 6 is a standard set of timings if you're running at like 4000 megahertz CL12, TCWL9, then this works. And for any other configuration of timings, it doesn't work. So, yeah, that's kind of that. So, you know, they're accessible, but again, I'm really, like, you know, I sometimes manually lock these in. I don't manually set them because there's a ton of rules that apply to these that I'm not entirely aware of. So, yeah. Also, they're actually motherboard dependent. So, you may find that, like, on the Gene, it might be like 49, 50, 6, 6. But, for example, with the ITX motherboard from MSI for 4000, well, I can't even do 4000 CL12 on that board. But when I was doing 3900 CL12, which seemed like that would normally run pretty similar timings, on the MSI board, that actually works out to like 49, 51, 6, 7. Okay, so you can see that there's like a slight timing difference. And then if you have like really different motherboard layouts, like for example a 4-DIMM daisy chain board, then you'd be looking at completely different timings again. So these are actually like board layout dependent, DIM dependent, memory timing dependent. They're like, that's why I basically call these magic. Like, no idea how specifically they work. So yeah. Anyway, then we get some I/O latency offsets. Not sure what these do either. And then we have whatever these are, which I don't know. These are still timings, but I'm not sure what they do either. You don't have to worry about them. You can leave them on auto. Even if you're doing extreme overclocking, you could probably leave them on auto. So that's kind of that. Next, we get another menu item full of settings that I just don't know what these do. Here we have memory training algorithms. So, essentially, these are all different procedures for the memory controller of the CPU to try figure out, things like the RTL timings and other settings for the memory during the boot up. And these are really important for stability, but you're probably best off leaving these all on auto. Because, yeah. Like, I've tried messing with these. I've not really gotten anywhere with it. These all exist. If you know more about DDR4 than I do, then, these might be very, very helpful to you. But to me, this is all just... No, yeah, I have no idea what any of these do. But there's a bunch of settings that you can play with if you feel like it. So, yeah. So I think that covers everything in this menu, including all of the submenus. Now we get to a menu I actually enjoy. Yay! So here's the Extreme Tweaker external digital plus power control. So here we have a bunch of VRM settings. And the first thing we get is, of course, our CPU or load line calibration. Now, a lot of people would be tempted to just max this out, because if you max this out, it'll get you a complete, level 8 is no V-droop, okay? Like, literally no V-droop. It says minimum right there, but it's no. It turns the V-droop off. Now, the thing is, for the sake of having decent CPU stability, you probably shouldn't be setting your V-droop that high, because essentially all it does is produce a whole lot of unnecessary heat and doesn't actually do anything for your stability. Yes, your load voltage is higher, but only within the frequency range that you're limited, that your Super I/O chip can see. So if you're actually, so basically for day-to-day usage or even extreme overclocking, I would honestly be hovering between sort of levels 5 and 6, maybe even level 4, if I'm trying to push some really high voltage for a benchmark that's really, power cycles really hard. Because the idea behind the V-droop is essentially the V-droop is supposed to try match the physical capabilities of your voltage regulator. In terms of how quickly it can adapt to changes in current draw. So turning the V-droop off, as tempting as it may be, will not necessarily give you any extra stability, but it'll definitely make your CPU run hotter because you're going to have a bunch of extra voltage under load. Well, it's not really a bunch of extra voltage, but the voltage will be higher. That's essentially what's going to happen. Like, your average voltage is going to be higher. Your minimum voltage may still be just as bad as if you set it to level 6, which is kind of the idea behind setting it to level 6, because your minimum voltage is going to be the same as if you had it at level 8, but your average voltage is going to be significantly lower, so you're going to be producing less heat, and your stability is not going to change. So, yeah, and level 6 is probably, for this board... is probably going to be the sweet spot, but you may want to mess with this yourself within your own stress testing. But I would say start out with level 6, and then try, one step down, maybe one step up, see which way it improves your stability, especially once you've basically run out of core voltage itself, right? Like, if you set your core voltage to where your cooling system can't sustain it anymore, that's when you can start trying to fiddle with the LLC. And I would, when you first start overclocking, I would really start at, level 5 or 6. That's where I normally start off with. And then once you figure out that, the voltage is, once you're I don't know, maybe you're at 1.35 volts V-core and you're still not passing, stress test, you might want to go to level 7 or level 5, might help you. Anyway, so we do have our load line calibration settings here, and I'll just set it to level 6 because that is my preferred setting. Then you have the option to synchronize this with the AC/DC load line of the CPU, but I honestly, I've never messed with that. That setting is unique to, I'm not... This is something to do with like Intel's power management stuff. So I'm not sure what exactly that's going to achieve. I normally just leave it disabled. So yeah, lots of other motherboards don't even have that setting available. So that's kind of that. Then we have CPU current capability. So this essentially, actually, they have a perfectly good explanation right here, right? A higher setting will allow the voltage regulator to supply more current, while a lower setting will cause the voltage regulator to shut down the system when the supplied current is higher than the set value. So essentially, this is overcurrent protection, right? CPU current capability, this is overcurrent protection. If your CPU pulls too much current, it's going to make the VRM shut down. This is a safety feature if your VRM is crap. If you have a gene, your VRM is not crap, but so you can just go and max it out. Okay, then we have CPU VRM switching frequency. This is stock at 500 kilohertz. You know, you can leave it on auto or you can set it manually. The idea behind cranking this up is that you can essentially improve your VRM output ripple. The downside to this is it lowers your VRM's efficiency. So you can get better voltage regulation, but worse VRM efficiency. It goes all the way up to 1 megahertz. I would not recommend going that high. For day-to-day usage, you're probably best off with just 500 kilohertz. If you're doing extreme overclocking, you may actually want to test out, you know, again, you're going to want to probably, like, I'd start at like 800 kilohertz, and then if I run out of voltage range, I'd probably try go up to the full 1 megahertz switching frequency, which is, like, it's 1,000 kilohertz. So all the way up to 1 megahertz. And check if that doesn't help with overclocking any further. It probably doesn't, because there's diminishing returns to constantly raising the memory frequency. I mean, VRM switching frequency. So that's kind of that. But for day-to-day usage, you can use it at 500 kilohertz or 600 kilohertz or whatever. I mean, the VRM on this board is quite, like, it is pretty damn good. So you can crank it up pretty high, and thermally it shouldn't be an issue. Next, we have CPU power duty control. And this, like, ASUS actually has this explained quite well. So this is for balancing the VRM thermals. This is for balancing the VRM current. If you have it set to current, then potentially you might be able to overclock a bit higher, but probably you're best off with just having it thermal balance. So that's kind of that. Then we have CPU power phase control. So this controls how quickly you have VRM phase shedding. So modern voltage regulators, as a method of minimizing your idle power consumption, like low load power consumption, they will turn off any extra phases that you don't need running when you're pushing like 10 amps, right? Like if you're pushing 10 amps through, say, 5 phases of 60 amp power stages, you're wasting a hell of a lot of power just turning on 60 amp power stages, because that requires a lot of energy to do. So modern voltage regulators, they'll actually disable the phases that aren't necessary at low current loads. If you're doing extreme overclocking, you don't care about VRM efficiency. If you're running day-to-day, you do care about VRM efficiency, and you might want to leave it on just standard or set it to like power phase response and set it to ultra-fast. Ultra-fast is going to be more aggressive with is going to be more like, yeah, it's basically like what it says right there. It's just going to be faster with turning on all the phases. If you have it set to regular, then it's going to be, slower. So, yeah. Regular is going to be more efficient. Ultra fast is potentially going to improve your overclocking stability. If you set it to extreme, then it's going to lock the VRM into running all of the phases all of the time, which is horrible for your idle efficiency. But it may actually help you with, overclocking stability, which is why it's labeled extreme, because it's meant for extreme overclocking. So, where losing a bunch of VRM efficiency is not really a problem if it means that I can run 50 megahertz more in some random benchmark. That's kind of that. Then we can adjust the VRM temperature limit. The minimum value is 120. It says 115 right there, but that quite clearly to me is 120. I would not raise this above... Quite frankly, I think that's a good cutoff temperature. You shouldn't adjust that. Even if you're on liquid nitrogen, you shouldn't really adjust that as far as I'm concerned. Like, because the thing is, if your VRM actually... Oh, they don't let you set it to 150. So, okay. Like, why would you even change it then? Like, there's not that much range on there. So, yeah, just leave it at 120 and leave it alone. Because, honestly, if your VRM is hitting, 140 degrees, you should just fix your VRM cooling. Not disable the thermal protection. Then we have thermal control. you can completely disable the temperature limit if you feel like it. This is a really bad idea, because if you covered your VRM with a pillow instead of a heatsink, this would actually potentially make it possible for you to blow it up. Because at that point, heat would actually like be getting trapped, on the VRM. So, yeah, I would never, like, personally, I don't disable temperature limits on VRMs. Okay, it's just like if the VRM is overheating, you need to get more cooling, not disable the over temperature system, because that's a safety feature. That's there to prevent the VRM from breaking. So that's kind of that. Next, we have DRAM current capability, which for like whatever reason you can like max that out. Honestly, just max that out. There's no reason to have the memory, like DDR4 doesn't pull enough power to that. I don't know why this board has a current limit. Like, this is one thing I've never seen on any other board. Like, why would you put a power limit on DDR4? I guess some of the server grade memory where you have like a ton of memory chips might pull a significant amount of power, but that won't even run in this motherboard, so that's not really a concern. So you can just max that out, because it works the same way as the current limit for the CPU. It's just like, why you'd have that enabled, I don't know. Then you have DRAM switching frequency, so you can change the switching frequency for your memory VRM. The board does have a 2-phase, which, is more than a lot of other motherboards out there have. Potentially cranking this up will reduce your VRM output ripple, can maybe improve your memory overclocking range. It'll definitely make the memory VRM less efficient, but that VRM doesn't really have massive, MOSFETs that take a lot of power to turn on and off. So, quite frankly, like when I'm working with this board, I just have that maxed out all the time, because why the hell not? It doesn't, like, it's not like the VCore VRM where you're, like that. The VCore VRM's switching frequency makes a bigger thermal impact, because you're switching a lot more current there. Here you're switching like single digits worth of amps. It doesn't matter, okay? Like, there's not enough power loss there to worry about it. Next, we get a whole bunch of boot voltage settings. So these are all basically for extreme overclocking. Because when you're on liquid nitrogen, you sometimes need a little bit extra voltage when you're just trying to get the CPU started. So yeah, that's what all of these are for. And these only get applied during the boot up period of the system. So you can, bump up the voltage during boot up, and then come back down to regular voltages after the system has started up and is, warmed up and running. These aren't useful for day-to-day usage. You don't have to worry about them. Leave them on auto. That's kind of that. Next, we get internal CPU power management. You have Intel Speed Step and Turbo. Yeah, you can disable Speed Step, which will disable your power, like idle power savings. If you leave it auto, it'll just be enabled. So if you're doing like benchmarking, you might want to disable that just to make sure that the CPU can't power throttle no matter how much it wants to. But if you're, running day to day, it probably makes most sense to just have it enabled for the extra efficiency. Disabling turbo boost on ASUS motherboards disables overclocking, so you're going to want to leave that enabled all the time. Then we have some power limits. I don't know what the auto values default to, but you're going to want to max those out. This is a time limit. Honestly, if you're doing overclocking, don't worry about it. Just ignore that exists. Then we have our AC/DC load lines. And so these are load line settings for the CPU if you're using offset voltage. So this is because the thing is, we've actually disabled, right? We've disabled SVID. So the CPU can no longer control the voltage regulator. So these, which are the load line settings from the CPU, well, the voltage regulator can't, they can't be applied to the voltage regulator because that's disabled. But if you were running offset voltage, then messing with those potentially could make sense. But I don't use offset voltage because that means I don't have to deal with stuff like this, right? It makes my life so much easier. Also, if you have the synchronize, that makes sense. So if you are messing with offset voltage, then you might want to have the synchronization enabled. But that's all there is. So yeah, that's all in this menu. And then we have TVB voltage optimization. Oh, that's the thermal velocity boost thing. That's some fancy boost algorithm. I really don't care about for those things. It's a desktop. It's not a laptop. Just run the highest possible core speed all the time. Like, who cares about a 100 megahertz single core boost if my CPU is doing, like, 100 megahertz doesn't make a difference, right? If it was like half a gigahertz extra core clock on one core, then sure, but it won't manage to do that. So it's like, I don't care. Anyway, next we get Tweaker's Paradise. My god, this BIOS is extensive. We're almost at an hour, and yeah, I mean, I expected this to happen. But anyway, so then we have real-time memory timings. So I think if you have the ASUS Mem Tweak It utility, which I don't use, you can adjust your memory timings in OS when that is enabled. The thing is, adjusting memory timings while in the operating system tends to be extremely unreliable, so I just wouldn't use that. Then we have FCLK settings. So, yeah, and I think this can sometimes help with memory overclocking, but generally you're best off just leaving that on 800 megahertz. You can change your BCLK during startup, so if you want to, you can have a situation where you're, like, essentially what that'll do is you could have something like, oh, I want to run 102 megahertz BCLK, right? And this is, again, for, like, extreme overclockers. This is really not for day-to-day usage. But you still want to start up at 100 megahertz. So basically, so you'll start up at 100 megahertz, so you'll go through your memory training at 100 megahertz, and then you'll get into Windows, but you'll already be at 102 megahertz BCLK. So it's basically a way of circumventing potentially like minor memory holes or memory training issues at the cost of potentially having awful stability by the time you get into Windows, right? Because you do have that extra 2 megahertz and the memory training wasn't adjusted for that extra frequency. So that's kind of that. I'm going to set those back down to 100. So that's Tweaker's Paradise. Then we have BCLK amplitude. So you can tweak the the amplitude of the BCLK signal. So this is potentially like it says right down there. Higher values may improve overclocking stability, honestly, I would just leave that auto day to day. If you're doing some extreme overclocking, it may make sense to mess with that and set it to like 1000 millivolts or 900 millivolts. The thing is, I've not spent that much time with a Gene on LN2 or even the Apex on LN2. I think on the Apex, I was spending most of my time at like 900 millivolts or 1000. And I think for max memory frequency, I also had to raise it when I was doing that, but, or at least I raised it for the hell of it. And I'm not sure that it had any impact, but, yeah, for day-to-day, you can leave that auto. If you're doing extreme overclocking, you're gonna want to, like, it may make sense to mess with that and try raise it, but, yeah. Next, we get BCLK slew rate. Similar idea. This can, like, similar idea. I think a lot of the time I just max that out. It can potentially improve stability. For like memory over, like if you're pushing really high frequencies, it can help. So it's kind of that. Then we have BCLK spread spectrum. Disable that generally. Just have that disabled. Disabling the BCLK spread spectrum will essentially, like normally there's spread spectrum is to like, yeah, it says right down there, it's just like reduce the EMI. And so if you have spread spectrum enabled, your BCLK will float around a little bit. So instead of being exactly 100 megahertz, it'll go up and down by say 0.5 of a megahertz or even a single megahertz, right? Which is why if you take like a screenshot with your BCLK spread spectrum on auto, you'll take your 5.2 gigahertz screenshot and it's actually like 5.197, and that's BCLK spread spectrum doing that. So if you disable that, your BCLK is just going to lock to one specific frequency. Then we have BCLK frequency slew rate, which I'm not sure what it actually does. So yeah, it might have something to do with if you're changing the BCLK, it could improve stability when doing that. So, yeah, but I've never had to use that setting, so I would just leave that auto. Next, we get DRAM VTT voltage. So this is DDR VTT. This is your memory. This is termination voltage for the memory sticks. Normally, this is going to be half your VDIM, and for whatever reason, they say 0.6 volts. It's only 0.6 volts if you're at 1.2 volts DIM. If you're at 1.5 volts DIM, it should default to 1.75 volts. This voltage, Messing with this voltage can potentially help stabilize memory overclocks. The primary use I have for this voltage is most of my Samsung B die. It can scale to over 2 volts. There's just one minor issue with it. It hates DRAM, like having the VTT, DDR VTT voltage higher than like 0.93 volts. So if I go to like 2.05 volts on the memory, the VTT would set to like that on auto. But that won't be stable, so I manually lock it down to like 0.93 or 0.94 or whatever it is that I need. And that can really improve stability when you're pushing super high voltages into Samsung B die. It also depends on what, like, if your memory kit even requires that, because there's a lot of memory kits out there where you can just whack 2.1 volts into them and they'll take it. They won't complain at all. And then there's my entire collection where it's like, oh, the VTT is higher than 0.95 volts. Blue screens everywhere. So that's kind of that. Anyway, for day-to-day overclocking, you're probably going to be best served by just not touching that setting at all. Then we get VPP DDR voltage. Not touching this is a great idea, because it doesn't do anything, ever. I've never seen this setting do anything. So just don't worry about it. It's a supporting voltage for the memory, doesn't do anything, okay? It exists. If it's not present, you're going to be, like, if this VR voltage regulator breaks, then yeah, you're going to have a really bad day. But you don't actually have to do anything with it. It doesn't do anything. Then we have DMI voltage. This is one of those voltages for extreme overclockers, which fixes a bunch of issues that crop up when you're at like minus 190 degrees Celsius, minus 190 degrees Celsius on the CPU. If this you have to basically dial this voltage in order to be able to run at very low temperatures. Because if you don't, then I think it's like your PCIe connectivity gets all screwed up. So this exists for extreme overclockers and extreme overclockers only. You don't need to worry about that. Same goes for this voltage. Again, dialing this in has a huge impact on like your cold boot bug and your cold bug. For day-to-day usage, it doesn't do anything. Internal PLL voltage, same thing. Extreme overclocking voltages down here. Then we have GTPLL. So that's for the GPU of the CPU. So that's a PLL voltage. And actually, all of these PLL voltages, you may need to tweak them on liquid nitrogen for day-to-day overclocking. They don't do anything. And I'm going to say this. The system agent voltage right here, tweaking this one if you're on like ambient, if you're doing like memory overclocking and ambient, raising that voltage just makes things worse. Like that's been my experience so far with my CPU. Now, if you are going to tweak it, you may find that your CPU might benefit, but generally they shouldn't. And for all of these voltages, if like the SA and the memory controller and all of these, if you absolutely can't, if you absolutely have to, for day-to-day usage, you're going to want to stop at around 1 volt for every single one of them. Like 1.1 volts max. Okay, you're not going to really want to go past that. But they generally don't do anything. And raising your system agent one, in my experience at least, makes everything worse. So I don't mess with that one. Memory controller PLL voltage, so that's for the memory controller. So like this could potentially help with memory overclocking sometimes. I've just never seen it actually do anything. So kind of that. Then we have PLL bandwidth. This is actually if I remember correctly, this is actually a core voltage that ASUS labeled PLL bandwidth for who knows what reason. Actually, I think it might be VCC PLLOC is what this is. But yeah, ASUS being ASUS is, they just can't label things reasonable things. They have to mislabel everything so that it makes it really difficult for other board vendors to copy their settings. So at least that's the justification. I don't think it actually achieves anything because ultimately the board, like if you're hell-bent on reverse engineering an ASUS motherboard, it's not going to be that hard. Okay, it might be expensive. It's not like doing things like this is just not going to stop anybody, as far as I'm concerned. So yeah, anyway, this is another one of those settings primarily for extreme overclockers, doesn't do anything for day-to-day usage. Then we have eventual DRAM voltage. So this is a fun one. So you know how we had all of those boot voltage settings for in the Digi Plus VRM menu, and there wasn't a DRAM boot voltage? Yeah, ASUS just like, instead of being reasonable, like basically how that works is like you can potentially find that if you're pushing very high memory voltages, the motherboard may have issues training at say 2 volts or something like that. So in that case, you might want to set like 1.85 volts, which tends to be like the highest voltage that is really easy for memory training. And then for stability, you're actually, after memory training passes, your eventual DRAM voltage is going to be applied and you're going to go up to 2 volts. So that's how that works. For day-to-day usage, completely useless, again, as with most of these settings. We're going to go back down. But that's why they're buried in the tweaker's paradise. And then we have eventual CPU standby voltage, which is just the same idea as like here standby voltage, right? So wait, is there not a boot standby voltage in here? There is. Why? Oh, well, I mean, ASUS BIOS. I guess they just added that into the Digi Plus menu and forgot about this. Or there might be a timing difference where it's like the boot voltage applies for a very short period during initial startup. And then during memory training, you know, during the training procedures, you get this voltage. And then when you're finally in Windows, you can go up to whatever you set as eventual voltage down here. So that's kind of that. Basically, all of these are extreme overclocking settings that you don't need to worry about in day-to-day overclocking. We get this AI features menu, which I don't know what any of this does. I don't particularly care. So, yeah, because it's auto overclocking. I have heard that apparently this isn't completely terrible, but I'm not interested. So we're just going to leave. So there, that covers the extreme tweaker menu. Let's move on to the advanced menu. It never ends. So there's these settings. I'm not even going to talk about what these are, but these exist. What's this? You can enable PCI. Yeah, so there's PCIe Express Management, whatever the hell that is, and that, and this, and that, and this. Also this. Platform miscellaneous configuration. Whoa, this is so not helpful. Oh, actually, they have decent explanation. So yeah, you can just pause the video if you want to know what any one of these does. That's kind of that, and read the descriptions. So then we have CPU configuration, which includes a whole bunch of CPU settings that are actually kind of a pain to look at because, yeah, it just kind of skips across. We have some, you know, you can enable and disable various CPU features here, so you can disable whatever that is. TCC offset time window. Oh. Temperatures. Some kind of thermal management thing for turbo boost, I guess. That's what that sounds like right there. Hardware prefetcher, enable, disable, adjacent cache line prefetch, right? So the usual, you can just enable, disable various CPU features here. Virtualization on off, CPU core temperature, so where does that top out? 115, so standard as with all motherboards. The main use for this, as far as I'm concerned, is if you're stress testing with something like Prime 95. And as I said earlier, it's like if you're at high voltages, that is stupid hard to cool. So it may make sense to raise your maximum CPU core temperature just for the duration that you're stress testing in Prime 95, and then lower it back down because for day-to-day usage, you really don't want to be roasting your CPU. Because it will accelerate your degradation. Like, very high CPU temperatures accelerate your CPU degradation. Okay, there's a reason why this normally isn't set to, like, normally that is at, like, 105 or something like that. So, yeah, and it'll thermal throttle even, but actually, where? Maximum core temperature. CPU when it reaches this temperature to prevent. So normally the thermal throttle should be at like 95 degrees or something like that. It might have changed. I've not been following what the default settings are that much. So anyways, so yeah, for stress testing, you can like max that out. But if you're doing day-to-day usage, I would leave that at auto. Okay, just generally just leave that at auto, or potentially even lower it if you have some really, you know, if you're running like very intensive workloads at very high voltages, then generally lower temperatures means CPU lives longer because it reduces your CPU's leakage, as well as it has a bunch of impacts on, like, essentially there's lots of thermally driven effects within the CPU that improves CPU lifespan as the CPU gets colder. Okay, so yeah, that's kind of that. So you can tweak that. And where does that actually bottom out? I guess it's 0. Oh no, there's a reasonable bottom. Then we have active processor cores. So if you're running like, if you're doing extreme overclocking, you're doing some competitive benchmarking, there's a lot of benchmarks that don't run on more than like 4 cores or 2 cores even. Right, so in those cases, you may want to lower your number of active cores because that'll raise your maximum overclock because there's less cores producing heat. And also, if you're lucky, the 2 cores that are enabled, you unfortunately can't choose a specific core that's enabled. That's a feature reserved exclusively for the HEDT CPUs so far. I don't know, maybe Intel will introduce it on LGA 1151 eventually, but currently, it's only X299 where you can X99 does it too, but X99 and X299 are the only 2 platforms where you can choose specific cores to enable and disable. But here you just kind of have to hope that the 2 cores that stay enabled are the 2 best cores on your CPU. So it's kind of that. For day-to-day usage, I don't know why you'd be disabling cores on your 9900K. That seems kind of like a waste of money because there's the 9600K if you don't like cores, right? You can also disable hyperthreading. Disabling hyperthreading makes sense again for benchmarking purposes because there's a bunch of benchmarks where hyperthreading lowers your performance because it puts a bunch of extra strain on the memory. I've forgotten what the word for this, but memory stuff in the CPU. Essentially, it puts a whole bunch of extra load on the memory. I've completely forgotten what word I was going to use. I've said it in other videos, but essentially for benchmarking, some benchmarks benefit from disabling that and not having, a million threads. Most of the time, if you have a properly multi-threaded benchmark, then you want that enabled. But there are definitely benchmarks where you'd disable that and go down to 2 cores or 4 cores or 6 cores or however many cores the benchmark can use optimally. So yeah, enable thermal monitor. You can disable temperature monitoring on your CPU, which just seems like a terrible idea. Similar to disabling temperature protection on a VRM, right? I really want to be able to. I mean, I guess if you're doing a silly YouTube video where it's can we cook food on a 9900K, then actually disabling that might be a great idea, except for the part where your 9900K is probably going to end up dying shortly after disabling that. But hey. If you get enough views, you might be able to fund a new one. Next, we have settings like boot performance mode. So this configures what CPU ratio you're at when you're in the BIOS and during the boot up procedure. So I just I don't bother with changing this. Just leave it auto. Then we have Intel Speed Step, Intel Speed Shift. You can enable that, disable that. Right, turbo mode. Which you have to keep turbo mode enabled. Remember, this is an ASUS motherboard. If you disable that, you can't overclock anymore. Then we have CPU C states. You can disable them or you can enable them, and then you can choose which ones you want to disable. So these are the various power saving states of the CPU. If you're doing benchmarking, probably just disable them. If you're running day to day, you want to leave it auto probably. CFG lock. No idea what that is, but it's a thing, and it's available. So, it's kind of that, yeah. System agent configuration, it never ends. Why doesn't it end? Oh, boy. Okay, well, there's not much in this, at least. So, VTD is some virtualization extensions, which, if you're doing virtualization, you probably want to enable that. If you don't do virtualization, you want to disable that, or I don't know, yeah. Then we have above 4G decoding, which is, that's for when you want to have a stupid number of PCIe devices, isn't it? Yeah, I think that was a comment on one of my previous videos where I came across the setting and I was like, well, I have no idea what that does because I've never needed it. So then we have memory configuration, graphics configuration. You can choose if you want to do CPU graphics or PCIe, iGPU multi-monitor, enable, disable, right? If you want to use your iGPU for extra monitor outputs, you can enable it, bam, multi-monitor with your iGPU. Then we have DMI configuration, so you can lower the link speed of your DMI connection. Your DMI connection is the connection between the CPU and the chipset. So yeah, if you have M.2 SSDs on your chipset and you set that to Gen 1, you're going to seriously bottleneck your M.2 SSDs. And potentially even some USB ports. So depending on how much data you're transferring over them. So you're going to want to leave that on auto. I guess for extreme overclocking, it could sometimes make sense to lower this because you might run into like high BCLK. Well, no, BCLK shouldn't affect this. But you could run into some stability issues with like cold or something. So yeah, there are settings there. Then we have PEG port configuration. You can choose PCIe link speeds. Unfortunately, there's really not that many PCIe slots on this motherboard. So, yeah. You know, again, like, well, no. On LGA 1151, there's never a reason to mess with this, as far as I'm concerned. So, it's kind of that. Well, I guess you might run into a device that like doesn't work at Gen 3, but the motherboard should auto configure for that. So just leave that auto. Then we have PCH configuration, PCIe Express configuration. What? This seems like it's twice. Oh, I guess that's for the PCIe slot that runs off of the PCH. Yeah, that makes sense, doesn't it? So yeah, that's for the X4 PCIe slot on the motherboard, which currently isn't populated, which is why we don't see any options there. Then there's whatever this is. I have no idea what that is, so that exists. Then we have PCH storage configuration, which we have a whole bunch of options for our SATA ports that, again, this motherboard doesn't have that many of because it's this weird MATX form factor. Well, it is MATX, but ASUS decided to just strip it down. Then we have management engine stuff. Not sure. And then that. I don't know what that does either. Then we have onboard devices configurations. You can disable your audio. You can disable your internet. You can disable all of the LED. Wait. Postcode. You can disable your postcode. I don't know why you'd ever want to do that because that sounds like a really dumb idea. I don't want to be able to troubleshoot boot errors. But hey, you can disable it if you feel like doing that. So there's stealth mode, aura off. You can disable your RGBs if you feel like it. Actually, I should turn that off. Okay, it doesn't apply immediately. So whatever. Wait, aura off. Yeah, postcode still works. Cool. So then we have specifically for the, wait, you can disable everything. Oh, disable everything, even the postcode. Then we can disable just the okay, well, that you can disable various blinky lighty thingies on the motherboard. That's what that does. Then we have USB power delivery in soft off state. Oh right, if you're in sleep 5 mode, I guess. Yeah, so if you want to charge things from your computer while the computer is still off, it can use standby power from the PSU because there's a 5-volt standby rail. So you can have that enabled or disabled. If you disable that, then you plug in something into your USB ports, and if your computer is turned off, it's not going to charge. If you do want to be able to charge things while your computer's off, then you want to leave that enabled. Then we have USB Type-C power mode. I mean, these options are self-explanatory down here, right? Yeah, pretty good. And you can disable your Wi-Fi and Bluetooth stuff as well. So that's that. And we have APM configuration, which is, I guess power management stuff. So whatever that does, whatever this does, restore power after, yeah, AC power loss, power off, power on, last state. Power on by PCIe, power on by real-time clock. Oh, you can set it to power on. Yeah, okay, that makes sense. Anyway, so you know, power management stuff. Then we have PCI subsystem settings. SRIOV doesn't pull up any more options. That's good. You can turn that on and off. Don't know what it does. USB configuration. You can have legacy USB support, enabled, disabled, XHCII handoff, enable, disable, USB. You can disable your various USB ports and enable them. So you probably want them all enabled, but I guess maybe if you're running into some issues with some of them, it might make sense to disable those. Then we have network stack configuration, which I don't know what any of this does, but it exists. So if you need these settings, this is where they are. Then we have NVMe. I don't have an NVMe device, so there's no settings for that. Cool. HDD, SSD. I don't currently have even an SSD plugged in because we are just going through the BIOS. So yeah, if there was stuff plugged in, you would see it in that menu over there. If we keep going down, we've gone through. So next we have the monitoring menu. Here you can see your CPU temperature, motherboard temperature, PCH temperature. Is that VRM temperature? Is it? It probably is because I have a fan on the VRM, so that would make sense. You can see your fan speeds, there's various temperature sensors on the motherboard that you can plug in. I don't have any of them plugged in because I don't use them, so that's why they're all NA. CPU fan speed, you have CPU, just various fan speeds here. Then you have flow rate for the pump. I don't know how that's calculated whatsoever. Seems oddly low and probably wrong, but sure. Then we have CPU, various voltage readouts. So we have CPU core voltage, 3.3 volts, 5 volts, 12 volts. I wouldn't generally trust these readouts too much, like especially for the high voltages. I'm not sure about this motherboard, but a lot of motherboards, they tend to be just completely off. Like measuring things where it's like if it was actually at that voltage, something would have already tripped a safety feature to turn off. So yeah. Anyway, then we have Q fan configuration, so you can adjust your fan settings. Why is there so many submenus? And no. Okay, so there's some automatic fan tuning system, chassis fan configuration, more fan settings. So yeah, there's fan settings for days. I gotta say I prefer Gigabyte's approach to fan setting control. Yeah. I gotta say, yeah, I prefer Gigabyte's approach to handling this. So, anyway, that's that. And we have a CPU temperature LED switch. Oh. I guess there's an LED that'll light up if the CPU is really down. Oh, yeah, if the CPU hits like TJ Maxx, it'll light up on the motherboard, so you get a visual indication. You know what would be better than that? If the postcode on the motherboard just acted as a temperature readout. There's like a lot of other board vendors out there who have that as I'm not sure that there's a lot, but there's at least one board vendor I'm aware of that has their postcode function as a temperature readout once you're in Windows. Like once the post procedure is over, the postcode turns into a temperature readout, which I think is pretty cool for the CPU. And actually, on some of their boards, you can even set it to like read out voltages and all kinds of fun things. So, yeah. But anyway, ASUS gives you a nice little LED that tells you, hey, your CPU's on fire. So that's useful. You can also turn that off. I don't know why you'd do that though. Then we have boot settings, so you can choose boot priority and other boot configuration stuff. So you have fast boot, normal boot after AC power loss, boot logo display, how long to delay. If you want your computer to start up super fast, you can set this to 0 seconds. But if you actually want to make it into the BIOS, you probably want to have it on at least 3 seconds, right? So it's kind of that. All of those settings. Then we have compatibility, which you might have to enable this depending on what GPU you're using or what devices you have plugged in. Then you have secure boot options, which have U8, and whoa, there's settings for days. So, yeah. I've never bothered with any of this stuff. So, that exists. There's that. And then we have this menu. So we have easy flash. So if you're flashing your BIOS, you can do it via USB devices. There's like some formatting requirements. Yes, I do want to leave. Then we have secure erase. So you can nuke your SSD from the BIOS. I do want to leave. Setup animator. What's that? I don't know what that is. So, oh, I assume that does that add animations to the BIOS? Just because the BIOS isn't like clunky enough already. We also need to animate it. Great, awesome. ASUS, basically I'm still annoyed by what I'm complaining about, if anybody's wondering, is the whole Well, actually, just the fact that, like, I can't see the cursor when I'm scrolling around, like, that already annoys me. Right? Like, where is the thing? Where is it going to stop once I let go? Oh, at the very top. Cool. Um, so, yeah, the last thing a BIOS needs is more animations. Then we have ASUS user profiles. So here you can save some profiles. I primarily use these for memory, when memory overclocking. There's a toaster profile. Nice. Name your profiles things that tell you what they are. Also, there's one thing worth noting is there's a character that I like using that this doesn't. Oh yeah, it doesn't support. So that works, right? An underscore works, but a dash doesn't. If you try to put in a dash, that doesn't. So you can't put in dashes into your names, and that's kind of annoying for me because for a lot of other on a lot of other motherboards, I just use dashes instead of underscores. But yeah. Anyway. Then we have SPD information, so you can check the SPD profiles of your memory sticks. And for some reason, well, I guess it's for the the weird extra high memory sticks that they have. But yeah, so you can check the SPD profiles of your memory sticks. Then we have this, which is the thing that installs a whole bunch of crap onto Windows when you first boot up with this motherboard. You're going to want to probably want to disable that. We have graphics card information, so it'll tell us some basic information about our GPU. That there is wrong. Actually, no, it might not be wrong. I forgot. We're on the GT710. So, yeah, okay, that might be right. Anyway, then we got load optimized defaults, right? You can reset the BIOS from here, save changes and reset, which it gives you a nice summary of all of the BIOS changes you've made. We're not going to save and reset right now. You can discard changes and exit, and you can launch. Do whatever that does. I'm not sure. I don't really care at this point. We need to finish. So then we have my favorites menu, which basically just has some like you can basically pick and choose settings from from all over the BIOS and just kind of put them into the my favorites menu. I'm not sure how to do that. Let's see if the F1 tells us. It's F3. Oh yeah, so you can just choose from this monstrosity right here which settings to add to your favorites menu, which can make your life a lot, like if you set up your favorites menu properly, I guess you could do a lot of things much faster. So yeah, that's kind of that. Then we have a main menu right here, which gives us some basic BIOS information and some security settings, and language options, right? So yeah. Anyway, I think at this point, wait, no, F6. Oh, there. So they do have the gigabyte style. Wait, does this work with a mouse? I mean, does this require a mouse? That's what I want. Oh, it doesn't seem to? Or does it? I guess it does require a mouse. Well, I hate this already. So, yeah. So there is a graphical fan profile tuning option with a nice graph. Unfortunately, you have to use the mouse, which is just no. Just no. So that's nice and awful. There's also the AIOC guide, and there's a search function in this BIOS, which I guess, let's see, TCW CAS. Ah, neat. Useful. So you can quickly find settings using that. And what else do we have? Oh, and you can, wait, will that disable the LEDs? Oh no, that's just access the LED on off. So yeah. That is the ASUS Maximus 11 Gene BIOS. It is very extensive because there's just we just went through it. There's all of the settings. If you want to have a BIOS with more settings than you know what to do with, this is the motherboard for you. Admittedly, most of these BIOS, most of these settings aren't useful. For data, more like you don't need to actually use most of the settings available. But yeah, there's a lot of settings. Hopefully this covered everything you were looking for. Unfortunately, I don't really, we're not going to go into easy mode because easy mode's useless. So, yeah. So that's the BIOS walkthrough. Yeah. lots and lots and lots of settings. Hopefully this was somewhat helpful. Unfortunately, I guess at this point it's kind of obvious, like, yeah, I don't know every setting there is, but like, I'd be surprised if there's anybody who knows every setting in this BIOS. Like, honestly, think about it. Like, I guess maybe, yeah, anyway. So that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, and there's also merch on Teespring. You can find links to both of those down in the description below. They help out immensely with running the channel. And also, huge thanks to the guy who actually funded the purchase of this motherboard. So, yeah, because without him, we wouldn't be doing this, because I wouldn't have a board to do this on. So that's it. Thanks for watching, and goodbye.